Hi everyone. Today's blog, we are going to do model training to deployment with very less code. So let's start. This is the notebook that I created. It is for the water quality. It uses LuciferML for machine learning models, and for deployment, it uses TrueFoundry. So let's begin. We'll start with importing and installing the libraries. So we'll install LuciferML, MLFoundry, Service Foundry, and Radio. MLFoundry and Service Foundry are the libraries from TrueFoundry which help us to track the experiment and deploy the model. Then LuciferML is my AutoML, which take away all the hassle and does the hard work for you while creating machine learning models. We will start by importing the libraries like this. We'll set the environment, host and API key. We will import ML Foundry and Service Foundry. We will get the API keys from TrueFoundry like this. These are the Kaggle secrets. We will read the data now. So we'll do the exploratory data analysis. So this is the data. So we have pH, hardness, solids, chloramine, sulfate, conductivity, organic carbon, trihalomethane, stability, and potability in the data set. The shape is 3200 records and 10 columns. Potability is our target here, which we are going to predict. We will describe the data set. So these are the statistics, count, mean, standard deviation, null. There are null values. So we will drop the null values. So this is the target. Like now we are doing the analysis on the target. So this is the potability. Potability has 1200 records for potable water and 811 records for non-potable. So this is the count plot. Now we are going to do some box plots. These are the visualization that I did. The pie chart. So 60% of water is non-potable and 40% is potable. And this is the correlation plot, which tells the correlation among the variables. We are going to do the distribution plots now. Most of the data is normalized. There is very minor skewness. This is the pair plot. Everything is like all the graphs are done plotly. This is the scatter matrix. From the above charts, we can confirm that there is very less correlation, and these columns, they are skewed. So we are correcting it. So for correcting it, we are going to use machine LuciferML. This is the model technique. We will train the logistic regression model. So this is how we create a model in LuciferML. We'll call the classification because this is a classification task. We'll do the predictor, LR for logistic. We'll get the parameters, feature, then fit it, features and labels. This is how we get the results. And we are going to store them in a dictionary. So this is how LuciferML starts. Preprocessing starts done. Logistic regression is trained. This is the accuracy. Then we are going to train other models like stochastic gradient descent, then the perceptron. So there are a lot of models in LuciferML. We are going to train the rich classifier, support vector machine, the k-nearest neighbors, decision tree. I'm not going to cover all these, but you can always come to this notebook and try out on your own. Then gradient boosting. Now our models is done. We will check which model performed the best. So from here we can conclude that the k-fold validation accuracy of random forest is more at 73.12%. It's a graph. Now we will do the experiment tracking and deploy the model using TrueFoundry. First, we will save the LuciferML model like this. We will log into TrueFoundry like this and log in with the API key. We'll create a new project named Water. First, we'll get the client using the ML Foundry and the API key. First, we will get the create the project, and this is the project. This is how the project is created. And then we will capture the metrics. This is like experiment tracking, the water model. So we'll capture the metrics. The metrics are captured here, k-fold accuracy, val accuracy. And then we'll log the metrics. We'll capture the parameters of the model, the artifacts. So this is how the model artifacts are captured. Then we will log the save model artifact, the path to the model like this. The model path will be like this, and the scalar will be like this. Then we will log the model. So the log model needs the name of the model object, the framework. The framework is sklearn, of course, because it's a random forest. In the description, so I just wrote my model. The model is saved now. You save this FQN because you'll be needing it later. Now we will log the dataset. So this is how we log the dataset features, the feature object and the label object. It will go in here, features and labels. Now we'll create the deploy.py file, which is going the service foundry is going to use for deploying the model. It is nothing but the Gradio app with which gets the client. Then we'll get all the runs related to water. We will choose the latest run. We'll load the model like this, the saved model. We will get the data set like this. Then we'll get a panda set of it. Then we're going to do some processing for the Gradio app. Then we will launch it. This is the interface, Gradio interface. Then we will, once the deploy.py, this is the first step. Once the deploy.py is done, we will gather the requirements. Now we will again overwrite it with the launch code. So this is how we launch a Gradio app. Now we will do the requirements. So this is how we will write the requirements of text. Now we are going to deploy our model in Gradio app. So the name of the service, build spec. So we are going to use Python build now because this is the Python board. We have created Python deploy.py. It is going to run on port 8080. Memory limit is 1500. That means 1.5 gigs, and memory request is 1,000. That is 1 gigs. So after the model, after this runs, your model will be published here. You can click on the endpoint. So this is the Gradio app. You can change and play with the values. And once it's done, you can submit it, and you will get the if the model is portable or not. This is the predictions. So that's it for today. Thanks for staying by. Bye bye.